Okay, everyone, this is Unit 10.1, but I'm going to make two videos, an A and a B for this unit. Okay, so this unit is about tangents, and the definition of a tangent line says that a tangent line intersects a circle at exactly one point, and that point is called the point of tangency. So if in our example, point A is where this line AB intersects with circle P. So point A is point of tangency. Now let's look at this line. It says a line is tangent to a circle if and only if biconditional, if and only if it is perpendicular to a radius. And in our example, look at line AB is perpendicular to PA, and that radius is between the center and the point of tangency. And now we have a 90 degree there, and that's how we know AB is perpendicular. Okay, so let's look at some of these practices. First question, we have to determine if AB is tangent to the circle P. In other words, we have to prove if angle A is 90 degrees or not. And to prove a right triangle, we use Pythagorean theorem that says a squared, which is this leg AP, plus 15 squared, which is the leg of AB, should equal to the hypotenuse squared. So let's see if they are of the same value. So that's 64 plus 225. And on the right-hand side, I should have 289. Now, if I do my addition here, I have 289 on the left-hand side, and I have 289 on the right-hand side as well. Therefore, this checks out. So yes, AB is tangent to P. Okay? Let's look at example 2. Again, we have to prove is AB tangent to circle P, and we have to prove if this is a right angle. So the hypotenuse now is 5 squared, and then the two legs is 14 and 11. So 14 squared plus 11 squared. Obviously, this is not going to work because 5 squared is 25. Is a lot less than 14 squared plus 11 squared. So no, this AB is not a tangent to circle B. Okay? So example 3 and 4 involves a little bit of algebra. Say if JK is tangent to circle L. So we know JK is a tangent line, which means that LJ would be perpendicular to JK. We have to find X. This now becomes a simple right triangle. All the circle is helping us to determine is that it's given that this is a right triangle. So therefore 7 squared plus 19 squared should equal my hypotenuse squared. And if you use your calculator, the final answer is 20.2. Same thing with number 4. I will ask you to do that, and I'll give you the answer is 14.2. Make sure you verify that. For number 5, I'm going to help you with it. Notice number 5, I'm asked to find out what X value is. Notice that they don't have, you may be wondering, let's call this JK, let's call this point M. You may be wondering, is X representing KM or is X representing the entire length of KL? Now, if X represent the entire, let's say if I use Y, this is what I would do. This is what indicates that Y represents the length of KL. But without this little arrows and whatnot, if it's just a letter there, that means actually x equals just the length of km, just this little stretch here, this blue stretch I highlighted. That's where x is. So we need to find out what that length is. Now, this obviously is a right triangle because we know that JK it's given. JK is a tangent line. So I have one leg, I have the other leg. I should be able to calculate the whole length of KL. So KL squared should equal 24 squared plus 10 squared. Notice KL, I know X, but do I know ML? If JL is 10, JL is a radius, LM is a radius as well. So here, LM, let me use a different color, the red part, LM is 10. So I can just replace that, substitute KL should equal X plus 10 squared equals 24 squared plus 10 squared. Okay? And if you solve for that, you should have x plus 10 squared equals 676. At this point, the easiest thing to do is to take a square root on both sides. So you would have x plus 10 equals 26. Therefore, x is 16. And that is your final answer for problem number 5. Let's look at number 6. Same thing here. 11 is all by itself, which means 11 is the length of the radius. Therefore, the entire length of MJ should be 11 times 2, which is 22. And if I have that, I'm asking for the length of the other leg. So it's x squared plus 22 squared should equal 25 squared. And this comes out to be 11.9 for x. That should be your final answer. Number 7, same thing. It's almost exactly the same thing. LJ is 3.5, so this whole length should be 3.5 times 2. So the whole length of MJ is 7. If I have that, I know JK is the tangent line, so my 90 degree is there. This leg is 6.4, so that's simply 7 squared plus 6.4 squared equals x squared. And your x should come out to be about 9.5. And I'll leave you to finish number 8 on your own, and the final answer should come out to be 12. Okay? Now on the next page you have number 9 here, and this is almost exactly the same. So, but it's a little bit more involved with algebra. So let's look at this here. JK again is the tangent line, so I've got 90 degrees here. And I know from the edge of the circle to K is 10. I don't know this side. However, I know that this side, I'm going to call this M. MK is 10. LM I don't know, but I know LJ is X. All the radius are exactly the same length. So if LJ is X, this has to be X. Therefore, LK equals x plus 10. That's the total length of the hypotenuse in triangle LJK. So now we have the hypotenuse. We just need to square it. And then we have the other 2 legs squared. Okay? So again, it's Pythagorean theorem. And here, let me write it on this side. There are different ways of solving it, but probably the easiest thing to do is to distribute this. Remember, instinctively, some of you will do this. You will just directly square the two numbers inside or two terms inside. And this is wrong. Cannot do that. Okay? The correct way of doing it is x plus 10 squared is x plus 10 times x plus 10. And if you FOIL, you should have x squared plus 10x plus 10x plus 10 times 10 is 100. So you should have x squared plus 20x plus 100. Okay. Notice the difference between here and here. You have the first term, x squared. You have the last term, 100. But over here, you lost the middle term, which is 20x. This is called the perfect square formula. You probably have seen this. A plus b squared equals a squared plus b squared, but in the middle, you have to use also add 2ab. So it's a squared plus 2ab plus b squared. That is your perfect square formula. So now we bring this back here. Since I've distributed this already, I'm just going to write it out. Notice that 20 squared, that's 400. That's a 4. Now I can minus x squared on both sides. And then I do a little bit more algebra. I should have 20x equals 300. Therefore, x equals 15. Okay? Yeah, I'm sorry, I should have switched back to blue ink on the left-hand side, but all the work here is done on the right-hand side, just FOIL. So let's look at some other properties. I just want you to know that this is called the ice cream cone property, or ice cream cone theory. What that says is that if two segments like AB and CB from the same external point B are tangent to a circle, then these two lines are congruent. So AB is congruent to CB. Okay? Another way to think about the ice cream cone is it's almost like the sun shining down on Earth, and you know the distance to both sides are exactly the same. And obviously there is between the point and the tangent, the center and the tangent point is a right angle. So this is called the ice cream cone theory. An extension to that is on the right. If a polygon is circumscribed, meaning around a circle, then all sides are tangent, meaning that the polygon has a circle inside, and in this case, the sides of the polygon, each side is the tangent line. Okay? Then it says all sides are tangent. Of course, we've got the tangent points there. And if you think about it, since we have our ice cream cone theorem, BE and BD should be congruent, right? One external point, two tangent lines, the two sides should be congruent. AD and AF should be congruent. And EC and FC should be congruent. So you've got three sets of congruency here. So, but it all goes back to the ice cream cone theorem. Let's look at number 10. I need to find x, but I'm not given much other than I've got an ice cream cone. So the tangent line on the left-hand side, BC, on the right-hand side, AB, which is 5x plus 23, should equal the same on the left-hand side, which is 8x minus 19. Your final answer is x equals 14. I will leave you to do number 11 on your own, and the answer should be x should be 3. Your final answer is looking for PQ, and that should be 29. Now let's look at 12. Not a lot of information is given, but it certainly looks like an ice cream cone, right? As abstract as it may seem. So let's see. We've got tangent lines here, ST and SU, and we've got an ice cream cone situation. So we can easily set it up as 10x minus 41 should equal 4x plus 7. And if you do that, your x should equal 8. Okay, once I find x, I can find that ST should be, so that's the first step. Second step, ST is simply 10 times 8 minus 41, and that should give me 39. And then finally, since I need to know SV, right, I'm looking for SV. So SV, in this case, I've got a right triangle here. So SV is the hypotenuse. SV squared should equal 17 squared plus now this one equals 39. So that should be 39 squared. And that should come out to be 1810. And if you take a square root, SV should be 42.5. So as you can tell, it's still the same thing over and over again, but it's just slightly more complex visual and sometimes slightly more complex algebra. Try to do 13 on your own. It's the same way. So if it's 11 here, it has to be 11 here. 16 here, it has to be 16 here. 9.5 there, it has to be 9.5. So then if you add it all together, you should have 73. Okay. And I will leave you with 14 to complete on your own. Your final answer should be 180. Okay, guys? And I will post a separate video about all the terminologies. All right, have a good evening. Bye-bye.